Sometimes you're composing more than two functions. Oh, let's try three functions. How about taking the derivative of sine of e to the x cubed power? That's really the composition of three functions. When you plug a number in for x, what do you do first? You cube it to get x cubed. That's the most inside function. What do you do next? You take that output and make it the power of e. You exponentiate. That's the middle function, or the second most inside function. The outside function is the sine function. So the derivative here, do I need a more general version of the chain rule then to figure this out? You could, but you don't have to. Break it down piece by piece, even though this thing is a composition in there. And so you need the chain rule for its derivative. Don't worry about that right away. Think of it as sine of that function, with the outer function being the sine function and the inner function being e to the x cubed. Chain rule says take the derivative of the outside. The derivative of sine is cosine. Plug in the inside. Then multiply times the derivative of the inside, which I'll use the ddx notation for because I don't yet want to do that. I don't want to actually take the derivative right away because I'm trying to be careful. But then when you take the derivative of e to the x cubed, you use the chain rule again. X cubed is the inside function, e to the x is the outside function. If you're tracking with me with all this inside-outside stuff, it's easy to daydream and not be paying attention to exactly what I'm saying. E to the x is the outside function. The chain rule says take the derivative of the outside function. The derivative of e to the x is e to the x. But wait a minute, plug in the inside function. Then multiply times the derivative of the inside function, which I could write as ddx of x cubed. But this is quick enough just to write the answer is 3x squared. That's the answer. Maybe simplest to write it like this. Let's double check this on Mathematica. The function, the original function, is this one, sine of e to the x cubed. Here's one thing to pay attention to. Use a capital S-I-N. Mathematica built-in functions like sine and cosine, for example, must start with capital letters. Inputs have square brackets, not parentheses. Remind you also about the underscore when you're first defining this function of x. Don't type ordinary e to the x cubed. Type capital E to the x cubed. Capital E is its own special function, the number e effectively. Raised to the x cubed power, probably good to use parentheses here, because you're wanting to make sure the entire x cubed is the power of e. Enter this, take the derivative. We did get the same thing. Okay? So you can use Mathematica to check. Here's one other new thing, though. Another way to take derivatives on Mathematica is with the built-in function called capital D. For derivative, square brackets. Let me just copy and paste this functional expression in here. I can put the function I want to differentiate inside of that, then comma x. That will also find the derivative with respect to x. Same answer. Sometimes that's more convenient if you don't feel like defining the function f of x.